Hey there. Ready to dive into this micronutrient article you sent? The one on essential micronutrients for critically ill patients. It's the 2023 Current Opinion in Critical Care article, right?
That's the one. It's got some really interesting findings.
Yeah, I was surprised by some of it, to be honest, like the whole thing about low micronutrient levels.
Right. You'd think it's simple, critically ill, low levels.
Hmm.
Just
Okay.
supplement that.
Exactly. But this article points out that it's not always so straightforward.
Not at all. One of the first things that jumped out at me was how low micronutrient levels in blood tests don't necessarily mean a patient is actually deficient.
Yeah, it's like a medical mystery.
Right. And inflammation seems to be the key. Basically, inflammation messes with where micronutrients are in the body.
So it's not always about how much is in the body, but where it is at that moment.
Precisely. Think of it like this. Inflammation causes micronutrients to move out of the bloodstream and into tissues.
Ah, so a blood test might show low levels even if there are sufficient amounts elsewhere. Sneaky.
Exactly. The article mentions that selenium, beta-carotene, vitamin C, they can all drop low in the blood during those first few days of illness.
And that happens regardless of how much inflammation is actually going on.
Yeah, which makes those initial blood tests tricky to interpret.
It definitely throws a wrench in things. So you really have to look at the whole picture, not just one blood test.
Absolutely. The context of their illness is crucial.
Couldn't agree more. And on that note, the article spends a good chunk of time talking about patients on CRRT.
Continuous renal replacement therapy.
Yeah? Seems it's a bit of a double-edged sword when it comes to micronutrients.
Definitely. It's a lifeline for these patients, don't get me wrong.
For sure, their kidneys aren't working right, so CRRT steps in to filter the blood.
Exactly. But here's the thing.
It washes out those essential nutrients, too.
It's, like you said, a conundrum. Filters the blood, which is essential, but it can also filter out some of those good micronutrients along the way.
So it's sort of like throwing the baby out with the bathwater, in a way.
In a sense, yeah. The study in the article specifically mentioned carnitine, copper.
Oh, and some of the B vitamins and vitamin C. Right, they can be depleted.
Yeah, it's a big deal.
It makes you realize how crucial it is to keep a close eye on micronutrient levels in anyone on CRRT.
Absolutely. This research really drives that point home.
Now let's talk vitamin D. Seems like it's always in the news, right?
Always something new.
So this article really digs into it, especially for critically ill patients. And, well, it's not as simple as low levels, take a supplement.
Not anymore. It's not just about soaking up some sun.
Right. And this is where it gets interesting because just giving high doses of vitamin D,
Could actually backfire.
totally. According to one of the studies this article talked about, megadosing can actually decrease the active form of vitamin D in the body.
Yeah, how crazy is that? More is definitely not better in this case.
And it's all because of this hormone, FGF23, which is stimulated by, you guessed it, vitamin D.
Right. And high levels of this FGF23 have been linked to, well,
A higher risk of death in critically ill patients.
it really adds another layer of complexity to it all, doesn't it?
For sure. You'd think giving more vitamin D would help these patients, but it could actually make things worse.
That's what makes this research so important. The timing and the way you give vitamin D, especially to critically ill patients, is crucial.
Absolutely crucial. Talk about a balancing act. Too much can be just as bad as not enough. Speaking of tricky balances, the article also dives into iron. Kind of essential, right?
Absolutely.
But they call it a double-edged sword.
Yeah, it's vital, obviously, oxygen transport, all that. But it's also involved in ferroptosis.
Ferroptosis. Okay, that sounds ominous. What is that exactly?
It's a type of cell death, and it's dependent on iron, which is where things get tricky.
So, unlike normal cell death, this ferroptosis thing,
It can be triggered by things like inflammation, infections.
which are often present in critically ill patients.
Exactly. So when you've got all that inflammation going on, too much iron could actually do more harm than good.
Because it could fuel this ferroptosis.
Exactly. It's all about context, right?
Absolutely.
Yeah.
So how do you even manage iron levels in critically ill patients then?
Well, the delivery method is important. Giving IV iron when there's active inflammation
Risky business.
could be, it's like adding fuel to the fire.
Right, right. So timing is everything.
The article mentions this study, the Iron Man trial, where they gave critically ill patients IV iron, and it did increase hemoglobin, which is good.
Right.
It didn't really reduce the need for transfusions.
Which is usually the goal, right?
Often, yeah. But that's where this other study comes in, looking at a molecule called hepcidin.
Hepcidin. That rings a bell.
Ah,
Remind me again.
it's like the body's iron regulator.
Right, right. Controls how much iron goes where.
And so this study, they used hepcidin levels to decide when to give iron.
So they were basically personalizing the iron therapy.
Exactly. Only gave iron if hepcidin levels showed a real deficiency.
And what they find?
Pretty amazing, actually. They saw a significant decrease in mortality, even long term.
Wow. So by using hepcidin to guide treatment.
They were able to give the right amount of iron at the right time.
Incredible. It really shows the potential of this personalized approach, even at the micronutrient level. But this brings up a good point because we've been talking about these individual nutrients, but the article stresses this idea that they don't work alone. What's the saying? Teamwork makes the dream work.
Something like that. It's not about just one player, it's the whole team. This article, they talk about this meta-analysis.
Oh yeah, the one looking at combined micronutrient approaches.
Yeah.
Instead of just giving one nutrient, they gave a whole blend.
Exactly. And get this, patients who got the blend, shorter ICU stays.
No way.
Less risk of infections, better outcomes overall.
So this holistic view, it really seems to make a difference. But what about carnitine? The article touched on that too.
Carnitine, super important, especially for how our bodies use energy.
Right, particularly for the heart.
And as you can imagine, critically ill patients, higher risk of being low in carnitine, especially those on CRT.
Double whammy for those patients.
And since it's so vital for the heart, getting those levels back up, it can make a big difference.
There was that study mentioned, right, the one with the critically ill kids on CRT. They saw some pretty amazing results. Something about myocardial strain, wasn't it?
Yeah, they found that giving carnitine actually improved myocardial strain, which is essentially a measure of how well the heart is pumping.
So by addressing this carnitine deficiency,
They were directly supporting heart function in these really vulnerable patients.
that's incredible. It really highlights how important it is to look at all these micronutrients, not just the ones we hear about all the time.
Mhm.
It's like we've been missing a big piece of the puzzle.
We're getting there, and the research just keeps getting more interesting. Like this article, it even touches on this cutting edge stuff, delivering antioxidants directly to the mitochondria.
Mitochondria. Those are the powerhouses of the cell, right? Isn't that where energy is made?
You got it. They make energy, but they also produce free radicals as a byproduct.
And those can cause damage, right?
Exactly. So the idea is if you deliver antioxidants straight to the source.
You protect the mitochondria, like giving those power generators some extra shielding.
Precisely. It's still early days for this research, but the initial findings are promising. They're seeing reduced inflammation, better heart function,
Wow. So protecting the mitochondria could have a ripple effect throughout the body.
potentially. It's pretty fascinating stuff.
It sounds like we've learned so much about micronutrients, but there's still so much we're discovering, like how low levels in a blood test don't always mean a deficiency.
And that more isn't always better, especially with things like vitamin D.
And the whole thing with CRT and how it can deplete certain nutrients, it's amazing how important it is to take that into account.
It's all about that delicate balance and the importance of understanding each micronutrient's role and how they all work together.
Exactly. It's been eye-opening. You've given me a lot to think about. Well, on that note, I think we've done a pretty deep dive on this one.
We definitely covered a lot of ground today.
To our listeners, if you want to learn more about this fascinating topic, you can find the full article, an update on essential micronutrients in critical illness, in the journal Current Opinion in Critical Care, 2023. Join us next time for another deep dive.